Right, good day everyone. This is grade 12 mathematics paper 1 probability. Therefore now question 11, let A and B be two events in a sample space. Suppose that the probability of A it is 0,4, the probability of A or B it is 0,7, and then probability of B is equal to K. Therefore now 11.1. So for 11.1, they're saying 11.1. For what values of k are A and B mutually exclusive? Therefore, now when we are talking about mutually exclusive, we don't have what we call an intercept. Therefore, now probability of A or B is equal to what? Probability of A plus probability of B. Right. Therefore, now we're given that probability of A or B it is 0.7, and then probability of A it is 0,4 plus probability of B, which is K, right? Therefore now K is equal to 0.7 minus 0.4, which is equal to 0.3. Very good. Therefore now 11.2. Right, and then for what values of k are A and B independent? Like independent. Remember, for us to have independent events, probability of A and B must be equal to what? Probability of A multiplied by probability of B. Right. Therefore, now probability of A and B is equal to probability of A, which is 0,4, multiplied by probability of B, which is k. Therefore, now probability of A and B is equal to 0,4 k. Right. Therefore, now probability, the general rule of probability, it says that probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Right. Therefore, now probability of A, we are given probability of A as 0.4 plus probability of B, which is k, and then probability of A and B it is 0.4 k. Right. Therefore now let's go and solve for k. Probability of A or B is 0.7, right? Let's go and solve for k. Therefore now we'll be left with 0.3, right? 0.3, which is equal to what? Which is equal to 0.6 k. It is 0.3, which is equal to 0.6 k. We divide by 0.6, we divide by 0.6. Therefore now 0.6 will cancel with 0.6. Therefore now our k is equal to what? 0.5. That's for 11.2. Let's go to the next question. Question 11. Question 11, they're saying Harry shoots an arrow at a target board. He has 50% chance of hitting the bull's eye on each shot. 11.1. Calculate the probability that Harry will hit the bull's eye in his first shot and his second shot. Oh, so we have a first shot and a what? And a second shot. 11.2. Calculate the probability that Harry will hit the bull's eye at least twice in his first three shots. Oh, okay. So now we have three shots. So then now for this kind of question, we have to construct what we call a tree diagram, right? For three shots, right? So we have three events for this tree diagram. Therefore now number one, the first branch. So then now when we are drawing the tree diagram, we will have the bull eye, right? He hit the bull eye and now he did not. So then now we have 0.5 chance, 50% chance, 50% chance. The second event, P M, right? P M, 0.5, 50% chance. Also here it is 50% chance. Remember, for each branch the total must be 1, right? 0.5 chance and also 0.5 chance. Then now the third branch, which is the third event, we're gonna have the bull the bullseye and what? And not hitting the bullseye. Hitting the bullseye and not hitting the bullseye. Hitting the bullseye and not hitting the bullseye. Hitting the bullseye and not hitting the bullseye. It is 0.5% chance, 0.5, 0.5, 0.5, 0.5, 5, 0.5, and then 0.5. So then now we, oh, I'm sorry, this is messy, but yeah. Therefore now 11.1, 11.1. Calculate the probability that Harry will hit the bullseye in. Okay, before 11.1, it is very much important for us to write these branches. I mean, like the lead, right? The lead for these branches. Therefore, now we're gonna have B, right? Hitting. Therefore, now it is B and B. Therefore, now B and B. Therefore, now the third one, it is also B. Oh, here it is BN, right? It's also fine. Therefore, now we're gonna have B and B, right? B and B. Therefore, now the fourth one, it is BNN, right? BNN. The fifth one, it is NBB, NBB. Right, the sixth one is NBN, NBN. Right, therefore now NNB, and the last one is NNN. All right, therefore now 11.1. Calculate the probability that Harry will hit the bullseye in his first shot and his second shot. Therefore, now probability of hitting, right? Probability of hitting the bullseye on the second, right? On the second shot. Therefore, now you're gonna have the probability of hitting the bullseye on the second shot. It is 0 is equal to what? 0.5 multiplied by 0.5, which is equal to what? 1/4, or 0.25, right? So then now the probability that he will hit the bullseye in his first shot and second shot, it is B. So like he will hit the bullseye twice, B. So then now B and B, therefore it is 0.5 multiplied by 0.5, which is 1/4. Therefore now 11.2. Calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots, right? In his first 3. So then now for us to find the probability that he will hit the bullseye at least twice in his 3 shots. Therefore now it is B. This is the first event, right? B. This is the second event. B. This is the third event. And then we also have the first one, right? B. This is the fourth event. Therefore now, for us to know that he will hit the bullseye at least twice, right? At least twice. Therefore now we must have at least 2B on our tree diagram. Therefore now we will have what? For the second event, the second one, it is 0.5 multiplied by 0.5 multiplied by 0.5, right? Plus the second one, 0.5 multiplied by 0.5 multiplied by 0.5, right? Plus the third one, 0.5 multiplied by 0.5 multiplied by 0.5 multiplied by 0.5. Plus the last one, which is the fourth one, 0.5 multiplied by 0.5 multiplied by 0 multiplied by 0.5, right? Therefore now our answer, it is 0.5, or one can say 1/2. It is still correct, right? So then now this is why it is important for us to draw a tree diagram, right? It is very much important for us to draw a tree diagram, because now it is easy now to see. We just look for 2 B's on each event, right? Therefore now this is 1, this is 2, this is 3, this is 4. Therefore now we have 4 events. Therefore now if we're having 4 events, therefore now there's 0.5 multiplied by 0.5 multiplied by 0.5. Therefore now we're gonna have 3 of these, right? Therefore now after these 3 of these, therefore now we're gonna find the answer of 0.5. Therefore now let's proceed. 11.3. Right, so then now 11.3, this question is very much interesting, right? So 11.3, Glenda, we have Glenda also has a 50% chance of hitting the bullseye on each shot, right? Harry and Glenda will take turns to shoot an arrow at the first person to hit the bullseye. Oh, Glenda will take turns to shoot an arrow, and the first person to hit the bullseye will be the winner. Okay. Calculate the probability that the first person who shoot first will be the winner of the challenge. Okay. So then now, firstly, the first person or the person who shoots first. So then now we will end up having. Oh, we want to calculate the probability. So then now the first person, right? The probability is 0.5, right? Now the second person. Okay, so then now this 11.3 is very tricky, but for you to understand it better, let's think this in rounds, right? Therefore now for round one, for round one, let's say Harry will shoot first in round one. Therefore now the probability for Harry to win immediately in round one, it is 0.5, right? Round two. Let's go to round 2 now. For Harry to get another chance in round 2, therefore now let's say Harry misses, right? The probability that Harry misses, it is 0.5, right? The probability that Glenda will miss, it is 0.5. The probability that Harry will hit now, it is 0.5. Therefore now we'll end up having 0.5 multiplied by 0.5 multiplied by what? By 0.5. Let's go now to the third round, right? Round 3. Therefore now for round 3, same idea again. Let's say now they both miss, right? They both miss. Remember, on round 2, Harry was the one who hit it, but firstly he missed and Glenda also missed. Therefore now let's say now on round 3, then Harry hits. He hits on the what? On the last round. Therefore now he missed, right? 0.5. He missed. 0.5. Glenda, she missed 0.5. She missed 0.5. Therefore now when it comes to Harry again on the other side, therefore now he will hit, right? So this is the sequence for you to answer this question. So all in all, we'll end up having what we call a series, right? So now if you can observe this, we have 3 0.5. Here we have 5 0.5, but now we started with only 1 0.5. Therefore now we'll end up having a series. We'll end up having what we call a series. And for you to understand this better, you must know that for this question, Harry and Glenda both have 50% chance of hitting the bullseye on each shot, right? They take turns shooting. The first person to hit the bullseye wins, right? So then we must find the probability that the person who shoot first win. And therefore now, as for me, I assumed that Harry was the one who shooted first. Therefore now that's why on the first round, I said Harry is the one who ended up shooting, and then now the bullseye. But for round 2, they missed. He missed first. Glenda missed again. Therefore now Harry hit the bullseye again. On the third round, they both miss. Right? Remember, we are having 3 events. Therefore now on round 3, they both missed. Right? They both missed. They both again missed. Therefore now on the third round, Harry hits, right? But Glenda missed. That's the third round. On the second round, Harry missed, right? Harry missed, which means Glenda is the one who hit it, right? The second round. oh, the on the second round, here is the one who missed, right? Here is the one who missed. Therefore now Glenda missed. Therefore now on the third one, here is the one who hit it. The bull, who shooted the bull's eye. Sorry, but the first round, here is the one who shooted first. So that's the sequence. We'll end up having a series which is 0.5, the first one, right? Plus what? 0.5. Remember, we're having what? 3 0.5. Therefore now let's proceed. The third round will end up having the 5 0.5. Therefore now this is the series that I was talking about. Therefore now for us to find the probability, this question is very much different. For us to find the probability, therefore now our A is equal to what? 0.5. This is a series, right? Therefore now we're going to have R. Our R is 0, the second term divided by the what? By the first term. Therefore it is 0.5 to the power 3 divided by 0.5, which is equal to what? Our R is equal to 0.5 to the power 2, right? 0.5 to the power 2, which is equivalent to 0.25. Therefore, now for us to find the probability, we can use sum to infinity formula, all right? Therefore, now A 1 over R, our A, it is 0.5, 1 minus 0.25. Therefore, now our probability is equal to 3 over 2. So this question was very tricky. It was very tricky because now we'll end up having what we call a series, right? A geometric series. It is a geometric series. Therefore now we have to find A, R. Therefore now we're going to have the probability, right? Because now the reason why we are ending up having a geometric series, it is because now we are taking turns, right? We are taking turns. They must take turns of shooting, right? So the one goes first, the other one second, the other one again on the third place to make a shoot. Therefore now we'll end up having what? A geometric series. This question is for 3 marks. I hope you understand. Therefore now let's go now to the following question 9. So for question 9.1, for two events A and B, it is given that probability of A it is 0.35, probability of A or B is 0.61. Determine probability of B if 9.1.1 A and B are mutually exclusive. Therefore now 9.1.1, if you are saying A and B are mutually exclusive, therefore now probability of A or B is equal to probability of A plus probability of B. Because now they are mutually exclusive, we don't have probability of A and B, which is the intercept, right? And therefore now probability of A or B is given as 0.61, probability of A is 0.35 plus probability of B. Therefore now probability of B it is 0.61 minus this 0.35, which is equal to 0.26. Very good. Therefore now 9.1.2. Determine probability of B if A and B are independent. Right, if A and B are independent. So firstly, you must know that probability of A and B is equal to probability of A multiplied by probability of B for independent events, right? Therefore, now the general rule for probability states that probability of A or B is equal to probability of A plus probability of B minus probability of A intercept B, right? And therefore now we have probability of A or B, which is 0.61, and then our probability of A it is 0.35 plus probability of B, which is the one we want, right? Therefore now minus probability of A intercept B, it is equal to what? It is equal to probability of A multiplied by B. Therefore now probability of A is we're given 0.35 multiplied by probability of B, which is the one we want, right? So then now I've replaced this probability of A and B with probability of A multiplied by probability of B, because for the independent events, therefore now probability of A and B is equal to probability of A multiplied by probability of B. Therefore now if you try to simplify this, you will find your probability of B as 0.4. Very good. Therefore now 9.2. Right. Therefore now they're saying a cell phone distribution company investigated the number of defective cell phones that they obtain from two suppliers, Axis Cell Phone, right, and Direct Phones. They recorded their findings in a contingency table. Therefore now Axis Cell Phones and Direct Phones, we have defective and none and not defective. Therefore now 9.2.1 determine the values of A, the values of A, B and C. Therefore now for us to find A, how can we find A? But we can first find B, right? We can say 600 minus 514, it is equal to what? It is equal to 86, right? That's for B. Is equal to 86. Therefore now we can say 50, this 86 minus 58 is equal to A, right? Therefore now our A is equal to what? 28. Therefore now for C, it is this 600 minus what? 384, which is equal to what? Which is equal to 216. 216, right? These are the easy marks, right? Therefore now C, it is equal to 216, and then A is equal to 28, and then B is equal to 86. Very good. Therefore now 9.2.2. Calculate the probability that a cell phone chosen at a random is supplied by a direct phones, right? Therefore now for us to probability that it is supplied by what? By direct phones. The direct phones, it is C, right? These are the direct phones. The direct phones. It is C. Therefore, now probability is equal to 216, the total, over the total of all things, which is 600, right? 600. Therefore, now the probability that a cell phone chosen at random is supplied by a direct cell phone, it is equal to what? Is equal to 0.36. Very good. And therefore now 9.2.3. Calculate the probability that a cell phone chosen at random is not defective. It is not defective, or it is from Axis Cell Phone and defective. Good. And therefore now for those who are not defective, these are the total of not defective cell phones. Therefore now it is what? It is we can first say probability of what? Of not defective, right? Of defective complement, and we're adding it. This or means adding, right? With the what? With the Axis phones and they are defective, right? Axis phones who are defective. Therefore now probability of D complement, probability that are not defective. The defective, remember I said the total of this line is 514. Therefore now it is 514 over what? Over 600 plus the probability that it is from Axis Cell Phone and it is defective. Axis Cell Phone and it is defective. Therefore now it is 58 over 600. Therefore now our probability is equal to 0.95. Good. Therefore now let's go to the following question. Question 12. Good. Right. Therefore now question 12. A company generates a 4-character code using 26 letters of alphabet and 10 digits from 0 to 9. The code is in the form letter, a digit, and letter, a digit. Therefore now 12.1. Determine how many different codes can be formed if the letter and the digits may be repeated. Good. Therefore now the letters, we have 26 letters multiplied by the digits. The digits, we have 10 digits multiplied by the letters, 26 multiplied by the digits, 10, and then now it is what? 67,600. Good. Therefore now 12.2. How many different codes can be formed if the letter D, F, I, Q, U, V may not be used? Therefore now for the letters, it is 26 letters in total minus 1, 2, 3, 4, 5, 6, right? Therefore now we will be left with 20 for now, right? The code may not start with W or Z. Therefore now 20 minus 2 for W and Z. Therefore now we have 18, right? The letters, I'm saying 18 because now the letters D, F, I, Q, U, and V should not be used, right? And then now the code must not start with W and V. So for letters, it is 26 minus this 6 minus this 2. Therefore now we have 18, right? Therefore now the letters or digits may not be repeated, okay? The code ends with an odd digit. Okay, it ends with an odd digit. Therefore now onto these 10 digits, the odd digits are 1, 3, 5, 7, and 9. So then now we have 5 odd digits. Therefore now this will end with 5 odd digits, right? Therefore now the letters and digits may not be repeated because now the last digit, it is an odd number. Therefore now we are left with what? We are left with 9 digits, right? Out of these 10, we are left with 9 digits because now the last digit has to be an odd number. Therefore it is 10 minus 1 odd number, which is 9, multiplied by. Therefore now for the letters, okay, because now the code may not start with W or Z, right? And yes, it will not start with W or Z. Therefore now onto this space, will either have Y or W out of 18 alphabets, right? Out of 18 alphabets, we will either have W or Z, but not both. Therefore now we'll end up having 19 alphabets, right? Out of 18, because now on the first one, they said we must not start with W or Z. Therefore now we have to minus this, which they said are not to be used. We said we would be left with 20 letters. Therefore now we minus the W and Z. Therefore now we're gonna have 18 letters. Therefore now onto this space here, therefore now we have to use W and Z because now it is not the start, right? We are on the middle of this or sequence or so. Therefore now we're gonna either have W or Z, right? It is not a sequence, they are just numbers, right? We're gonna have W or Z. Therefore now onto this 18, we're gonna add W or Z, right? It's either we're gonna have W or Z. Therefore now we're gonna have 19 letters. Therefore now if we multiply these together, we're gonna have 15,390. Good. Therefore now not 11, 12.3. The company wishes to increase the number of 4 codes informed in 12.2, right, by allowing letters D, F, I, Q, U, and V to be used. Calculate the percentage increase if the number of different codes can now be formed. Okay, so then now out of these 26 letters, sorry. Therefore now the first letters now, because now D, F, Q, U, and V, now they can be used, but this law still applies. The code may not start with W or Z. Therefore now for us to start a code, we have 24 letters because now out of 26 letters, we are minusing W and Z multiplied by. Therefore now the codes end with an odd digit. It still applies, right? Therefore now we have 5 odd digits, right? Therefore now if we out of 10 digits, we minus the 1 odd digit, we're gonna have 9 digits. Therefore now multiplied by, because now we can use D, F, I, Q, U, and V, but we have to add W or Z, right, in the middle of these numbers, W or Z. Therefore now it's either we're gonna have W or Z. So we have 25, which is equal to what? 27,000. Therefore now for us to calculate percentage increase, it is 27,000 minus this 15,390. We divide that number by what? By 15,390, right? And then now, because it is percentage increase, we multiply by 100. We multiply by 100. We multiply by 100. Therefore now, if you punch this in your calculator, your answer will be 75. Sorry, not 95, but 75.44%. Therefore now, this is the end of our session. If you want more questions like this in physics, in chemistry, in lab science, paper 1, paper 2, and so forth, please don't hesitate to call or WhatsApp the number on the description below for fully detailed sessions and detailed explanations of these questions and sessions if you want. Therefore now, this is the end of this session. Thank you for watching.